So my name is Mike Caprio, and I am the lead organizer for Space Apps NYC, which is the New York local chapter of the International Space Apps Challenge. International Space Apps Challenge is a NASA-mandated event. It's been held since 2012. This is our fourth year here in New York City, and we have been the global main stage for the event for the last 2 years. It's an international hackathon. So, judging by the name, it's International Space Apps Challenge. NASA every year comes up with a series of challenges in different themes. And this year the themes were Earth, outer space, robotics, and manned space. And they asked the general public to help them solve these problems. So here in New York City, we've had approximately 1,100 people sign up over the last 4 years, and we've created almost 100 different open source projects to improve life on Earth and in space. We have our different ways of contacting us here on the slide. We have a 300-person meetup group. We'll be going to the Intrepid Museum Space and Science Festival on this Thursday to Sunday this next week. And at the bottom is our YouTube channel, Space Videos, where we had over 36 speakers attend our conference this year in Times Square with Friday night Women in Data Bootcamp, headlined by a number of women executives from NASA leadership, as well as leading tech industry executives, including Minerva Tantoko, the CTO of NYC. And then a number of renowned speakers. We had 3 different astronauts there for the weekend, and of course our weekend-long hackathon solving problems. So here we are in Times Square. We had about 400 people attend this year, and they actually lined up as early as 5 in the morning. Microsoft was our intergalactic sponsor this year, and they gave us their headquarters in Times Square. They have 2 floors of the whole building. And we had approximately almost 200 hackers this year, and then a number of conference attendees and guests. And this is a diagram of all the participants we had of the Space Apps Challenge this year, the green indicating the size of the number of participants. It's a truly global event, and this year was our biggest year ever. We had nearly 14,000 participants worldwide in 133 locations in 64 countries.
Could you go back to that other?
Sure.
Those are explosions, right?
Yeah, population explosions.
I mean, wow, I'm impressed with Australia.
Well, we call it the galaxy's biggest hackathon. It is literally the largest mass collaboration internationally that has ever been held, and it's with a government agency. The truly most incredible thing about it is that NASA is it's a government-funded agency for the United States, but it is a globally minded organization, and this is a truly international mass collaboration where everything that is produced is an open source project and is released in the public domain for anyone in the world to use.
Minnesota
So the United States has approximately several dozen locations. We actually had quite a lot. The U.S. and Europe are our biggest participants, although we see a lot of. Cairo was one of our biggest. I'll show you. So you can see here over time from 2012, our humble beginnings. We only had about 20 sites the first year. And 2,000 people attending, and then a huge jump to 9,000, 8,000, and then this year nearly 14,000. And you can see too the number of solutions produced. This year was our biggest year. Almost 1,000 different projects were created. And it's all across the board. The nature of the International Space Apps Challenge is to be an inclusive and diverse event. Like, we want everyone from every kind of background to participate. As you can see, barely a third, or just slightly over a third of the people there were actual developers. We had game designers, artists, storytellers, students. Students make a very big showing. Yeah, and we have, this year in New York City, we partnered with the Museum of Natural History, which has a program called Bridge Up STEM, which is a program for underrepresented groups, for girls and minority kids in high school and middle school to learn about. That's me in the back. That is me. Yeah, and here you can see one of the girls from the AMNH participant who took part in the Women in Data Bootcamp from Friday. and then came to her very first hackathon, here at the Space Apps NYC International Space Apps Challenge. We try hard to be an inclusive and diverse event, but we really haven't had to try that hard because space is a very, very widely, everybody loves space. Is the best way to put it. Space is the place. We had approximately, all 4 of our events over the last 3 years have had about 50-50 gender ratio, which is very unusual. And we additionally had daycare at our event this year for all 3 days of the conference. So we went with a really excellent outfit called Sitter Studio, and they provided infant and child care for people who normally would not be able, and it's not even a gender issue when it comes to daycare. It's about, being inclusive for families as a whole.
You know what? That really makes sense because women, obviously at home, definitely have more opportunity to, get on the laptop. I know it's all day with a child.
Well, when the key to having a diverse perspective is to be inclusive, and that's really the true goal of NASA creating this grassroots innovation program, is to get perspectives they don't normally get, and to get people participating who really want to help but normally aren't the traditional model of participant. So as you can see, this year was a fantastic year for women in data, for NASA making it a big focus of their program. And here again, several of the girls from the AMNH, American Museum of Natural History STEM program. So the bottom line is all of this stuff is available. There are 4 websites where anyone with really any sort of interest in doing development can go to: code.nasa.gov, data.nasa.gov, api.nasa.gov. There's been a real push over the last several years to make every single piece of software and everything that NASA does freely available open data. So as open source is about more than just software, it's also about making data available to everybody. And again, it's public domain to the entire world. So you can even find the software that ran the lunar modules at software.nasa.gov. So I'm going to talk about a couple of other interesting projects as well that just sort of underscore the fact that outer space is now achievable to everybody. Just this last August, there was a mission to reboot the International Sun-Earth Explorer, which was a spacecraft that was sent out to explore orbit the Earth and study the sun, and then went out to actually rendezvous with a comet. It was actually 1976, and it was on a return course back to the Earth, but NASA didn't have the resources available to sort of reestablish contact with the spacecraft. So a small group of very dedicated amateur aerospace people reestablished contact with the spacecraft, and were actually able to control it, working in partnership with NASA.
Were there any women in that group?
That's a good question. I can't answer that question. I'm not sure.
Well, the thing is, now this was launched in '76. It was
Yes.
tracking a comet.
It was so originally its first mission was to study the heliosphere, to study the magnetic radiation coming off of the sun. And once it completed that mission, a physicist figured out a way to create this really complex set of trajectories around the moon and the Earth, and to accelerate it so that it could then send out to, it actually flew through the tail of a comet, and then came back in a sun orbital trajectory back towards the Earth. So this is the one chance in a really long time to try to grab, they wanted to recapture this spacecraft and set it into an orbit around the Earth again. And they almost did it. They were this close. They were 90% of the way there. But unfortunately, they believe that, well, it's a several decades old spacecraft that's been in space, all this time, and they believe that it lost some of its propellant because when it flew through the tail of the comet, it may have been pierced by a micrometeorite. So.
What about the one there was one that landed on a comet?
Yes, that's the video I'll be showing at the end. So Dennis Wingo, who actually came to Space Apps NYC this year as a guest and gave a lecture, talked about this. You can see the video online at Jump to Space Videos. And he discussed the actual mission that they underwent and how they were able to partner with NASA Just basically, NASA is so open to working with anyone that if you can just prove that you know your stuff and that you can succeed at the goals that they set for you, that's exactly what happened. They were going to give these guys their own spacecraft to study the Earth. And they used open source software to reestablish contact. Because as you can imagine, a several decades old spacecraft, they had no more equipment. They had no more radios. NASA had gotten rid of everything they would have used to communicate with it, which was all built 40 years ago. Exactly. This spacecraft didn't even have a computer on it. It literally was just a remote control, like radio. You would send a radio signal to remote control it.
Probably like a regular television remote
Well, a radio signal. But the radios that were used to communicate with it no longer existed. Even the software and everything else that was used no longer existed. So they had to rebuild it from scratch to do what they called technoarchaeology, to create a software radio, which using the GNU free radio software. So again, open source software made it possible for these guys to rendezvous and remotely control a spacecraft that was returning from a 40-year mission.
So this spacecraft, I'm trying to think, like, it used 76, did it use some sort of solar?
Yes, it did have solar panels. Yep.
That's like stuff they built there.
Well, if you remember back in the day, Jimmy Carter put solar panels on the roof of the White House. It's been a long time that solar technologies existed. We just haven't subsidized it in this country. Special interest. That's exactly right. In fact,
Guys who buy their shoes because of oil, really expensive shoes.
if you're interested in learning more details about the condition of the spacecraft, you can watch the video. And he explains how basically they were able to get data. They got telemetry back from the spacecraft. It was fully active and working. The only thing it didn't have was the propellant in order to move it back to a stable orbit.
So this thing didn't have a computer. It was basically camera.
Just like we have drones today, where you could just like a model aircraft and you could remote control it. That would be exactly the same thing. You were sending a radio signal to fire part of it.
So the information that it was sending back was basically radio.
Yes, exactly. It had a radio on board, and it would receive. It had a transmitter and a receiver, so it would receive a radio signal, just like a remote control car, and it would move or change its position.
What information were they getting?
Well, they were getting back information about radiation, information about the sun, right? So like all different types of detectors and instrumentation on the spacecraft. But again, you can see all that on the video. It's fascinating.
Without a computer on board, it's like everything radio signal.
Exactly. I mean, that's how they had to do it back in the day. So again, open source software saved the day. So there are other ways to partner with NASA and to work on space. You could actually get a satellite sent into space for free by NASA using their CubeSat launch initiative. So currently NASA, they've created this open standard for what they call micro or nano satellites. They're 10 centimeters long on a side, and you can put a solar panel on them. You can use off-the-shelf technology like smartphones. You basically create this thing, and then they send it up as an auxiliary payload with one of their launches, and then shoot it out into space. So you could literally have your own satellite. You could do your own science missions. You could do your own educational missions.
How big you said?
10 centimeters on a side, so about 6-ish inches or so.
You get your little satellite like this.
Yep. You could put cameras on it. You could put a smartphone in it, some other kind of detectors or science. So, that's actually being done. So a few different examples of. The cool thing about it is it's free, right? Like normally it would cost maybe up to $100,000 or more to send a piece of equipment into space. It's exactly right, actually. So this is an example of a CubeSat using what's known as the Arduino, which is an open source hardware platform. It's called the ArduSat. And they put a number of different instruments on it, a Geiger counter, a vibration sensor, a temperature sensor, et cetera. And it just uses solar panels to power itself and then can communicate back to Earth using radio signals. So here are some more examples of different types of CubeSats. The PhoneSat is just like you said, it's an Android smartphone, again, using kind of like this open source or almost open source platforms to do, it's basically putting a computer on the satellite and doing much more sophisticated technology. There are also LightSail is a popular CubeSat that just went out. Bill Nye ran a Kickstarter. Bill Nye the Science Guy was the CEO of the Planetary Society. Just successfully launched a prototype of the LightSail, which is a solar sail to propel itself as a satellite through space. And you can see up to $300,000 has been raised. And actually, I believe that's an older that's old infographic. So I believe it's much more money now. So yeah, so the opportunities are there, and you know it's really fantastic that NASA's undertaken a program like this.
How is this advertised? Like, this is
I'm doing the advertising right now.
so the first time. I mean, we hear all kinds of shit in this place. This is the first time I'm hearing about this.
I would love to, if anyone from UNUSA is watching, I would love to speak with you about possible opportunities to partner here in New York City for Space Apps next year. But yes, this is a fantastic program. I really feel that this year is our breakout year for Space Apps. You know, we've been doing it since 2012, but having 14,000 participants worldwide this year and producing almost 2,000 open source projects over the course of the last 3 years.
A lot of space things happening.
We're making a really significant impact, and we're putting space in the hands of grassroots innovators.
What's cool is too. Besides that, you know, you've got like free advertising with all the what was that last mission that just passed Pluto?
Yes, New Horizons. In fact, I'll be showing you some videos just now.
That's interesting, man.
Hey, do you remember that game Laser Tag?
Yeah,
You guys should like rent little drones for everyone to like do laser tag.
that's a great idea. That's a great. In fact, laser communication is being researched right now. So sending light through space to do rapid communication is absolutely a thing that's being happening. So the last thing I want to talk about is our Space Apps NYC's partnership with the American Museum of Natural History, and an event that we held there last year called Hack the Universe. So over the course of a weekend, we held the very first overnight hackathon in the museum under the Hayden Planetarium, using the APIs and data that the Museum of Natural History has for astrophysics and astronomy. So here's a couple pictures from the event. Here's people hacking in the Rose Center for Earth and Space, next to the Willamette meteorite. It's probably the coolest hackathon venue ever, because it looks like you're on Star Trek, basically. And it was a fantastic event. We built about 30 projects in about 36 hours. We had about 150 people attending, and some incredible projects came out of it. It can all be found on GitHub. Right there at the end, at the bottom, is the API that was created for the digital universe, known universe data set that contains all stars and all observed celestial bodies that the Museum of Natural History has in their data set. And that's just a group photo.
Is that the list of stars that they were raising money, like selling you? You can get a star, you can buy.
Well, so the museum doesn't do that commercially, but in terms of the open data, you could create your own. You could use the open data to create your own sort of map of the stars, which actually several people did. One of the projects that was created.
Something NASA had like a couple of years ago. Where,
Mhm.
you know, they had like a number that they can visually see, and they had a limited number, but you can purchase a star
Mhm,
or
mhm.
something like that. Have your, you know.
Yeah, there's a number of different naming services and stuff out there. But the cool thing about this was the museum actually had several projects that were created at this that turned into exhibits. So the museum actually came to Space Apps NYC this year and showed off several of the exhibits that they created back in April of 2015. And one of them was this really fun thing called Starface, where you would look into a Microsoft Kinect, like an Xbox Kinect. It would take an image of your face, and you would plot points on your face to make a constellation out of your face, and then it would actually map them to real stars. It would find the stars that made your face.
You're in the belt. You're in the belt.
So I'd like to talk about another program that the museum will be partnering with us on called OpenSpace.
I gotta run up.
So OpenSpace is a open source software platform that the Museum of Natural History is working with a Linköping University in Sweden to do visualizations of actual celestial events. So I'll just skip over to one of the videos here. This is the Comet 67P. which is the Rosetta mission ESA lander, the comet that we landed on recently. And you can see, yeah, the music builds, but basically what you're seeing now is the trajectory of the spacecraft as it closes in on the comet. So you'll see it now. Here's photos of the comet. It takes a little time to build up. Yeah, it's totally working. Yeah, it's coming. Yeah, it's coming. The music should start now. It's right here in the front.
I don't believe it, man.
It's super quiet.
Just look.
There we go.
Oh, yeah, it's happening.
So as you can see, the three-dimensional representation, this is actually all the stars you see in the background are the actual positions of real stars. This is a full simulation of space.
That one should be a little more to the left.
So what was it using to get the? I saw that the pattern. Was it swinging around?
So that purple line that you see there is the actual trajectory of the spacecraft as it closes in. I'm not sure why it switched over to a different view. Oh, okay. So as you can see, the spacecraft, as it circles in, gets closer and closer, and then sends its lander, which lands on the surface. And that three-dimensional representation there is only 12 different photographs that are superimposed upon a 3D object. You can see the sun in the background there and the planets revolving around it. And then the spacecraft getting, that's the trajectory of the spacecraft. So it's now leaving and getting into a more stable orbit around the comet after it dropped its lander on top of the comet. So that's an example of the kind of visualization that you can make with the open space software. But as you were saying, the New Horizons mission is very much in the news now, and the Museum of Natural History partnered with the New Horizons mission to create simulations also of their spacecraft. So what you'll see now in this next video is 2007. This is all real telemetry, real data and trajectories of the New Horizons spacecraft as it took images of the planet Jupiter in 2007. In fact, you can see up here, this is actually the date and time, the exact date and time that the craft was making its pass. And so there's the simulation of the craft, and you can see the lines coming off of it are the imaging, the cameras, the instrumentation on the spacecraft, and you'll see it's going to pass over the surface of Jupiter, and then the actual photos that were actually taken of Jupiter by the instrument will be superimposed onto the surface of the planet as it moves through them in real time. So you'll see, right, like the Great Red Spot will show up as we get down a little bit closer, and it's just layering those images of one over the other, showing the cloud patterns. And this exact same thing was done just last Tuesday when the New Horizons spacecraft made its closest approach to Pluto. I got to attend there in the morning as it was actually happening in real time. So I'll switch over to that video now.
But now with that thing, it went to sleep. Is that what it was? And they were saying how like 7 hours before they were afraid.
Oh, that's correct. Yeah, just before they entered a fault-tolerant mode, and then had to effectively just like wait it out and have it reboot itself. Yeah. So now this is the actual event itself, and there'll be some voices talking here.
Pluto passing in front of stars.
So that's Carter Emmert, the director of astrovisualization at the museum, and Neil deGrasse Tyson's in the background as well.
NVIC actually uses called TDI, or time delayed imaging, and so that strip they use the scanning, they use the motion of the spacecraft. It's using fuel, I believe hydrazine, so that it's just moving very slowly, and they have star trackers, and they also to know that their aiming is just right.
So again, this is real time. So as it was happening, this is really the only way to explore space when it's billions of miles away, is to virtually simulate it.
Okay, keep, okay, you can keep going now, sorry.
Yeah, this was on Tuesday, on Bastille Day.
Michael, you can navigate now again.
You may not navigate.
We're going to come back to Orpan to talk us through what approach this is going to be the ESPN play-by-play.
They had echo on the presentation.
Astrobiologist and author David Grinspoon is going to join us with some big picture thoughts, because he's pretty psyched too.
Yeah!
Back to Orpan.
Well, here we go. We're now doing a scan of Charon. Can we put zoom in on it? See what we're seeing on Charon
Yep.
as well. And so
now the same
see
process
now
is
the-
happening. It's
the
imaging the
frames that are being
surface,
taken.
but we don't have the photos yet because we haven't
That-
we can't
and
superimpose
it's
until we get them.
actually happening as we speak.
Because I saw this
And,
thing the other day, and they were
yeah,
pretty
and
surprised.
Sharon,
that this
we
doesn't
probably
have
discuss it
so many
another time,
impacts,
but also
Mhm.
have
you
very
know, and
interesting
it's way
structures
out
on its
the go.
surface as well. Beyond just cratering, there appears to be some geology as well. And now we're going to have this high-resolution data, as I mentioned before, and we're going to be able to reconstruct those three-dimensional topographic images. And so and you see now the scan is now continuing off
Thank you
disk.
very much.
Sure thing.
and just taking those photos. And now, how much time we have before closest approach? We have, oh my God, I think it's about now. It's exactly now. We have just passed through closest approach. Yeah, so there we go. Wow, we have now crossed over, in a sense, into the third zone. And it's a momentous occasion. I'm kind of almost beside myself with joy, and it's amazing. And the things that are going to be revealed to us are going to be quite unimaginable. We are going into the third zone of the solar system, and this is going to be a place where new doors are going to open up, ways that I think none of us have imagined. And Pluto has opened that door for us already. You see that there are so many things we don't understand, and it's staring right back at us as we pass on through. Wow. You want to?
So as you can see, space exploration, very exciting, even when it's just a virtual in simulation and open source software. So if you have any interest in that open space platform, it's actually available for in source code. It'll be on GitHub. They just had an alpha release of the first binary in celebration of the New Horizons mission. And they are actually going to start asking for people to join the community to work on the development of this, because it's a multi-platform simulator. You could use this open source software to create virtual reality for a virtual reality headset. You could use it in a planetarium. In fact, it was being used for a digital planetarium in Ghana to simultaneously broadcast that New Horizons Pluto flyby in Africa in real time when it was happening. So just go to that URL, j.mp open space list, to sign up on the mailing list, and you can get the software and look at the GitHub repository from the open space website at the bottom of the screen there. So thank you very much. My name is Mike Caprio, and there's my information at the bottom of the screen. Hope to see you at our next Space Apps NYC event. Thank you.